Hello students, welcome once again back to study filtration operation. So this is the seventh session of the fourth unit of the particulate technology course. So the recap of the previous class. In the last class you studied about the working principles of vacuum filters and also applications we discussed along with the advantages and disadvantages of vacuum filters over other types of filters. So then we studied in detail the rotary drum filter, which is a continuous vacuum filter. So we discussed about its construction and working details and also the applications. So these are the topics that we are taking up in today's class. So we are going to discuss about the resistance to the flow of filtrate in a filtration operation. So here we're going to understand what is the cake resistance or what is the resistance offered by the filter medium to the flow of filtrate. So we also will be deriving equations to calculate or to estimate the cake resistance and the filter medium resistance in a particular filtration operation. So the resistance to the flow of filtrate exists in various ways. So in the channel in which the feed is introduced and the channel through which the filtrate goes out. So those channels offer some resistance to the flow of filtrate, and also the cake that is getting deposited on the filter medium also offers a great deal of resistance to the flow of filtrate, and also the filter medium which retains the solid and allows the passage and provides the passage for the flow of liquid, that is filtrate, also offers a resistance. So the total resistance present in a filter for the flow of filtrate is the sum of all these three types of resistances. Okay. So one is a solid that are retained in the form of cake and the filter medium. So along with the channels meant for introducing the feed and taking out the filtrate. So all these offer the filter resistances. So there are three resistances to the flow of filtrate in series. One is the resistance of the feed and the filtrate channel. The other one is resistance of the cake deposited and the resistance offered by the filter medium. So let us now understand what is the extent of resistance that is offered by these three elements in a filter. So comparatively, the resistance in the feed channel and the filtrate channel are negligible compared to the resistance of the cake and the resistance offered by the filter medium. So we can neglect the first resistance, which is very much less compared to the other two resistances. So the resistance offered to the flow of filtrate is the sum of resistance offered by the cake and the resistance offered by the filter medium. So when we say the filter medium resistance, it is a resistance offered by the filter medium and also some of the solids that get entrapped inside the filter medium during the early stages of filtration. So in the initial stages, when the filtration starts, so the initial layer of the solids that are separated, so will block the pores of the filter medium. So means that they get trapped into the filter medium. So that combined particles and the filter medium actually forms the true filter medium. So from there onwards, that combined trapped particles and the filter medium is considered as the filter medium for the flow of rest of the filtrate. So the resistance offered by filter medium means the resistance offered by the entrapped particles and the filter medium together. So then the resistance offered by the cake means it is the resistance offered by all the deposited solids in the cake except the solids that are already entrapped in the filter medium. So that gives the resistance offered by the cake. Now let us see how we can estimate the pressure drop across the filter medium. The overall pressure drop, that is the difference in pressure between the upstream side and the downstream side of the filter medium, is denoted by delta P. So since we have neglected the resistances in the inlet and the outlet channels, then delta P will be just the difference between the pressure at the inlet and the outlet respectively. Okay. So if you write that equation, it becomes delta P is equal to PA minus PB. So PA is the inlet pressure, PB is the outlet pressure, that is below the filter medium, this is above the filter medium. So the difference is delta P. Now we can add and subtract a term to this equation on the right hand side. We can just add P dash and subtract P dash. So if you write the equation like this with the P dash, where that P dash is nothing but the pressure at the interface between the cake and the filter medium. So now the PA minus P dash will be the pressure drop across the cake, then P dash minus PB will become the pressure drop across the filter medium. So this difference is taken as delta PC, that is the pressure drop over the cake, and this difference is the pressure drop over the filter medium. Okay, so that is how we can write the overall pressure drop across a filter medium and the cake together. So delta P is the overall pressure drop, PA is the inlet pressure, PB is the outlet pressure. So P dash is the pressure at the interface between the cake and the medium. So delta P is the overall pressure drop. So delta PC is the pressure drop over the cake and delta PM is the pressure drop over the filter medium. So this is the equation that gives you specific cake resistance. That is the resistance offered by unit thickness of the cake. It is denoted by alpha and it is equal to delta PCA divided by mu U MC, where the delta PC, as we already know, is the pressure drop across the cake. A is the area of the filtering surface in the direction perpendicular to the flow of filtrate. Then mu is the viscosity of the filtrate, U is the linear velocity of the filtrate, MC is the amount of solids present in the cake. So let this equation to be equation number 2. The first equation is the equation of pressure drop. Delta P equals delta PC plus delta PM. Okay, this is U and mu is the viscosity, MC is the total mass of solids in the cake. So in SI system, the units of specific cake resistance alpha is in meter per kg. So that is the resistance offered by unit mass of the cake. Then now let us write the equation for filter medium resistance. The filter medium resistance can be defined by the equation delta Pm divided by Rm equals mu U. So keep this as equation number 3. So here delta Pm, you know, it is a delta pressure drop across the filter medium. Then Rm is the resistance offered by the filter medium. Mu and U are the viscosity and the velocity of the filtrate respectively. So we can rearrange this equation to get an equation for Rm like this. So Rm is equal to delta Pm divided by mu U. So call this as equation number 4. So Rm is the filter medium resistance and the unit of Rm in SI system is meters. So again rearranging the equation number 2. We get delta Pc is equal to mu U mc alpha divided by A. So you know equation number 2 is the equation for the specific cake resistance alpha. So if we rearrange that equation to get an equation for delta Pc, so it becomes delta Pc equals mu U mc alpha by A. So you all know what are these terms stand for in the equation number 2. Now call this as equation number 5. So delta Pm equation can be obtained by rearranging equation number 3. So accordingly, delta Pm is equal to mu U Rm. So call this as equation number 6. Now we can substitute these two equations in equation number 1. So which is delta P is equal to delta Pc plus delta Pm. So equation number 5 gives you delta Pc and equation number 6 gives you delta Pm. So mu u mc alpha divided by A plus mu u Rm. So in this equation, the mu u term is common in both the terms on the RHS. You can take that outside and rewrite the equation like this. So delta P, that is equal to delta Pc plus delta Pm, is equal to mu u into mc alpha divided by A plus Rm. So keep this as equation number 7. So in this equation, we can replace U and MC in terms of V, capital V, that is the volumetric flow rate of the filtrate. That is total volume of filtrate collected in time T. So that V can be used to replace U and MC in the above equation like this. So MC is related to V by this equation. MC is equal to C into V, where that C is the mass of the particles deposited in the filter per unit volume of filtrate. So that into V will give you the mass of solids that are deposited on the filter medium. So call this equation number 8. In the same way, we can relate the linear velocity of the filtrate to the volume of filtrate collected per unit time. So as U is equal to dV by dt divided by A. Okay. So that is how we can relate the MC and U to volume of filtrate collected in time t. So now call this as equation number 8 and 9. So now if we substitute in the equation number 7, let us see what kind of change takes place. So here, as I already told you, V is the volume of filtrate collected from the start of the filtration till a time t is reached. Substituting U and MC from 8 and 9 equation in equation number 7, we get, so delta P is equal to mu dV by dt by A into CV divided by alpha A plus Rm. So we can rearrange this equation to write the dt by dV is equal to mu by A delta P, so into CV by alpha A plus Rm. So dV by A delta T. So if you can rearrange the equation like this, so we can take the reciprocal of both the right hand side and the left hand side. So dt by dv can be written as dv by dt. So in which case this a goes to numerator, that can be taken to the denominator on this side. So that is equal to mu delta p divided by mu, and you can shift this whole term to the denominator. So then it will be mu into Cv by alpha A plus Rm. So here this is the equation of the form rate is equal to driving force divided by resistance. So dV by A dt is the rate of flow of filtrate in the operation. Delta P is the pressure drop. So that is the driving force for the flow of filtrate. Then at the bottom what you have is the resistance. So mu is the viscosity, the resistance that exists within the fluid, and Cv by alpha A is the cake resistance and Rm is the filter medium resistance. So equation number 11 expresses the differential or instantaneous rate of filtration per unit area of the filtering surface as the ratio of pressure drop, that is the driving force, to the product of viscosity of the filtrate and the sum of cake resistance and the filter medium resistance. So let us now write the equations for constant pressure filtration. So in a constant pressure filtration, delta P will be constant. So V and T are the only variables in the equation number 10. Okay. So writing the equation at T is equal to 0, V also will be equal to 0. Delta P will be equal to delta Pm. So equation becomes dt by dV equals mu alpha Cv by A square delta P plus mu Rm by A delta P. So we can take this entire set of terms in the first part of the right hand side. So all this is together constant can be taken as Kc, and this entire term again is a constant can be taken as 1 by Q naught. So now call this as equation number 12. So where Kc is equal to mu alpha C by A square delta P, and 1 by Q naught is equal to mu Rm by A delta P. Okay, so now we can integrate the equation 12 between the limits t is 0, v is 0, and when t becomes t, v becomes v. So integrating the LHS between 0 to t and 0 to v on the right hand side. So what we get is t is equal to kc v square by 2 plus v by q naught. So that is the equation number 15. Substituting and 13 and 14 equation in the 15. So what we get is t is equal to mu alpha c by 2a square delta p v square plus mu rm divided by a delta p. So taking mu and delta p outside, being common terms in both the parts of the right hand side. So inside the bracket what you get is c divided by 2. V square by a square can be written as v by a whole square plus rm into v by a. Okay, this is the equation number 16. So that v has been left out here. So just forgot to write that v here. One v term is missing out here. And the second term on the right hand side. So the actual equation here is t is equal to mu alpha c by 2 a square delta p v square plus mu rm by a delta p into v. So that v remains inside the bracket. Rearranging equation number 15, what we get is t by v is equal to kc by 2 into v plus 1 by q naught. So rearranging the equation in this way is to get a straight line equation, so that when you plot t by v versus v, you will get a straight line of slope kc by 2 and intercept 1 by q naught. So using that plot we can estimate the cake resistance and the filter medium resistance. So this is how you get a plot. When you plot t by v versus v, get a straight line like this. The line has a slope of kc by 2 and the intercept will be 1 by q naught. So by knowing that, and also by using equations 13 and 14, both cake resistance and the filter medium resistance can be calculated. So let us now write down few equations for constant rate filtration. When the filtrate flows at a constant rate, the linear velocity u will be constant. So then u is equal to dv by dt by a will become simply v by at. So keep this as equation number 17. Then alpha will become delta pca by mu u mc, equation number 18. Then mc is equal to c into v, equation number 19. So substituting u from equation 17 and mc from equation 19 in the equation number 18 and rearranging, you will get the cake resistance equation in the form of delta pc divided by alpha is equal to mu c by t into v by a square. So this is your equation to estimate the cake resistance in a constant rate filtration. So let me end the session with that. So some YouTube video links are given here, which help you watch a video related to the topics that we have taken up in the session. So this is what we studied today. So what are the resistances that are present for the flow of filtrate in a filter. So how cake resistance exists and how it can be estimated. Then we learned how a milk filter medium resistance can be calculated for a particular instance of filtration. So let us go through a few questions now to understand how far we have understood the topics. So during filtration operation, the filtrate encounter the resistance of filter medium, cake, channel carrying slurry to the upstream side of the cake, and filtrate and the channel that takes the filtrate away from the filter medium. All ABC. So in the starting of this session, we learned that the flow of filtrate uh, faces three resistances. One that is of the filter medium, one that is from the cake that is getting deposited, one due to the friction in the upstream side channel and the downstream side channel. Okay, so it is all ABC. That is a correct answer. So filter medium resistance is that offered by filter cloth, particles entrapped in the filter medium, or it is the filter cloth and the particles entrapped collectively act as a support base for the filter medium. Okay, so among these options, so you all know that the true filter medium in a filtration operation is the filter medium plus the particles that are trapped in the openings in the filter medium. So it is a filter cloth plus the particles entrapped collectively. So that is the option in this question. So filter medium resistance is important during dash of filtration. Is it the early stages? Is it the final stages? Is it the entire process? Is it none of the above options? So actually, the resistance offered by filter medium is very important in the early stages. So as this filtration proceeds, the cake that is getting deposited offers greater filter medium resistance to the flow of filtrate compared to the filter medium. So that is due to the increase in the thickness of the cake as the time progresses. So only in the early stages, the filter medium resistance plays an important role. So for this question, the answer is option A. During the washing of cake, all the resistances are constant. Filter medium resistance increases. Filter medium resistance decreases. Cake resistance decreases. So washing of the cake takes place at a constant resistance because so during the washing only the clear liquid flows through the filter cake and the filter medium. So there is no much alteration to the resistances that already present in the washing cycle of the filtration. So all the resistances that are present will be constant during the washing of the filter cake. Unit of specific cake resistance is gram per centimeter square, centimeter per gram, centimeter per gram square, gram per centimeter. So in SI unit, SI system, we know that the unit is meter per kg. So the CGS unit will be centimeter per gram. So option B is the correct answer for the question number 5. So question number 6, the filter medium resistance is controlled by pressure drop alone, flow rate alone, both pressure drop and flow rate, and then cake thickness. So filter medium resistance is controlled by the pressure drop as well as the flow rate of filtrate. So it is not connected to the cake thickness. Cake thickness offers its own resistance called cake resistance. So filter medium resistance depends on the pressure drop as well as the flow rate. So both pressure drop and flow rate, option C is the right choice for answering this question. A straight line is obtained on plotting the reciprocal of the filtration rate versus the volume of filtrate for dash flow of filtrate. So if you plot on a graph the reciprocal of the filtration rate versus the volume of filtrate, so you get a straight line. In which case? So is it in case of compressible cake and laminar flow? Is it the incompressible cake and the laminar flow? Or is it the compressible cake and turbulent flow? Is it the incompressible cake and turbulent flow? So usually the cake that is incompressible, and whenever the flow is laminar, so during that time this variation will be linear. Okay, so option B is the right answer for this question. The specific cake resistance for compressible sludges is proportional to delta P, it is pressure drop, proportional to 1 by pressure drop, proportional to square root of pressure drop, independent of pressure drop. So cake resistance is not depending upon the pressure drop across the cake. So it is independent of the delta P. So accordingly the answer is option or D. The specific cake resistance for compressible sludges is a function of the pressure drop over the cake, over medium, overall pressure drop, none of this. So cake resistance for compressible sludges actually depends on the pressure drop. Okay. So that pressure drop which is existing over the cake, not over the filter medium. So it is not even the overall pressure drop. That is the sum of cake and the filter medium pressure drop. So it depends on the pressure drop over the filter cake. So the specific cake resistance for compressible sludges is a function of the pressure drop over the filter cake. So with that, let me conclude the discussion. So hope all of you followed the topics that we discussed in today's class. So again, we'll meet in the next session to solve a few problems on filtration. Thank you again for joining me. See you again in the next class.